Okay, chemical equilibrium is when the forward and reverse reactions are taking place at the same rate. So equilibrium always means something is equal. In this case, it's the rates that are equal. This is considered a dynamic equilibrium because we're going forward, we're going back, we're going forward, we're going back at the same rate. It appears to stop because the changes are equal. So concentration of all reactants is constant with time. Concentration of all products are constant with time. They're not constant with each other. Okay? Anytime we're in a closed container, we're going to reach equilibrium. Because look here, if we have an open container, if we produce a gas, it could leave. We can't get an equilibrium between reactants and products if one of them leaves. Typically, we think of a reaction going to products, and we use that single arrow. For an equilibrium, we need to use a double arrow. But if the reaction goes almost to this, then we would say the equilibrium position lies far to the right because we would have a lot of this and very little of this. So we use the double arrow to show that the forward reaction and the reverse reaction go. You might also see a double arrow written like this. You might also see a double arrow written like this, which would be like what we had right here. If the reaction goes almost to completion, you could show it like that to show that the forward reaction is the favored one. So let's look at a graph for this reaction right there. Okay. There are our reactants, and so it starts out, they are decreasing, and then they level off. Our products right here, when it starts out, we get an increase with those, and then they level off. When they level off, we're at equilibrium.